Hey, welcome back to phazertech. So today I'll be continuing my DIY pedal guide, and we'll be building the circuit for a Fuzz Factory clone, which is an extremely unique fuzz that can do some crazy oscillation effects. The Fuzz Factory circuit is quite small and doesn't require many components, so it should serve as a good introduction for beginners. However, this fuzz isn't for everyone. If you currently don't own a fuzz and you're wanting to build your first one, then I'd suggest starting with a different one first. The Fuzz Factory has a reputation of being noisy and difficult to use. The controls are highly interactive with each other, meaning turning one knob will affect the others as well, and it's easy to go overboard with the oscillation effects. However, if you already have a fuzz that you're happy with and are looking for something more experimental, then the Fuzz Factory should be an excellent addition to your collection. Here's a short clip to get a better idea of how it sounds. Later in the video, once I'm done building it, I'll see if I can mimic those same sounds you just heard. But let's save the fun for later and get to work now. If you haven't seen the first part of this guide, then I suggest you watch it as it serves as an introduction and covers a wide range of topics, many of which I'll be continuing in this video. It also covers the components you'll need to buy. Before I start, here's a list of all the equipment and tools you'll need for preparing the strip board and soldering it. I'll go into more detail on each of these items as I use them throughout the video. So the first thing we'll need to do is cut the strip board to the size that's listed in the layout, and drill holes in the board to cut the appropriate traces. So first use a Sharpie to draw an outline of the circuit. In this case, the dimensions are 13 holes across and 9 holes down. Make sure the traces are going from side to side instead of up and down before you draw the lines. Next, these red symbols here indicate a cut in the trace, which means we'll need to drill a hole at these locations to break these traces. Mark each of these holes on your board with a Sharpie as well. Now we're ready to cut it and drill it. I recommend doing this outside and also wear a mask and goggles since the board will release toxic particles when drilling it. First, use a thick pair of cutting pliers to cut the board along the lines you drew with the Sharpie. Make sure the sharp end of the pliers are directly on top of the line, then firmly press it to cut the board. You should get a clean cut like I did here. If you're not getting good results, then you can also use a saw to cut it as a last resort. But again, be sure to wear a mask and goggles since sawing it will release a lot more particles. After it's cut, you can use sandpaper to smooth out the sides. Now it's time to drill the holes we marked. I recommend using a 5/64" drill bit, which is about the same size as the traces. After you're done drilling all the marked holes, take a 3/32" drill bit, but use it with your hands this time. Spin it around back and forth in each hole you just drilled to finish them off, and this will ensure that each trace has been completely broken. Visually inspect the holes to make sure they're broken. You can also use a multimeter to test for continuity across each hole if you want to be absolutely sure. It's also a good idea to wipe the board clean with a cloth and rubbing alcohol. Also, I recommend wearing gloves while drilling and handling the drill bit, since dust particles will probably irritate your skin. This time I neglected to do so since it's such a small board and I was able to finish it quickly. But I made sure to wash my hands immediately afterwards. Now we're ready to solder the components onto the board, so let's talk about some of the tools and materials you'll need for this. First, I suggest getting a quality soldering iron, such as a Hakko or a Weller, which will cost around $100. There are some lower cost models which should work fine for this application, and 30 or 40 watts should be plenty, but they're harder to work with since they're not temperature controlled, so I recommend getting a model that has this feature. As far as tips go, I suggest using a chisel tip that's around 2 or 2.5 millimeters. You'll also want to get tip cleaner, such as this brass wool tip cleaner here. Another useful item to have is solder wick, in case you make a mistake and need to desolder something. Also, while working on the board, you'll need something to hold it, so you'll also want to get a PCB holder like this. Helping hands will be useful for soldering wires and other things too. As far as solder goes, I recommend getting 60-40 tin lead solder with rosin core. I suggest avoiding lead-free solder unless you're a masochist. Honestly, it's only going to make things a lot harder, and there's really no safety benefit from using it. Either way, the fumes of solder will be toxic, especially if they contain rosin, so in either case I recommend getting some sort of ventilation. I created my own ventilation system using fans, a cardboard box, and a hose that carries the fumes outside. It's a low-cost solution that you can pretty easily make yourself, and it works extremely well. At the very least, I recommend working next to an open window with a fan, so that the room doesn't fill up with fumes. Also, you might want to consider wearing gloves, or taping your fingers like I did to make sure solder doesn't accumulate on your fingers before touching food. Alright, now we're ready to solder on the components. I like to set my soldering iron to at least 700 degrees Fahrenheit, which is a little hot, but it allows you to work faster since it requires less time for the iron to be touching the components. If you're new to soldering, you should practice on a different board first, and maybe start at around 600 to 650 degrees to get the hang of it first. As you get more experienced and are able to work faster, then feel free to turn it up. When it comes to soldering, less is more. You want to make sure you melt just enough solder to completely seal the hole. Going a little overboard is okay, but if you put too much, then you run the risk of creating unintentional bridges between the traces. So try to be frugal with the solder. Also, be sure to clean the tip before you put the iron back on the stand. Alright, so the first thing we're going to solder are these links you see here on the layout. The leg clippings left over from used capacitors and diodes are perfect for this, since they're usually quite thick. But I don't save the legs clipped from resistors since those are typically thinner. If you don't have any clippings, then you can also use stripped solid core wire as your links too, and cut them to your required lengths. When placing the components on the board, I recommend using tape to secure them in place before you turn over the board to solder them. Clip the legs off after soldering them. After you solder all the links, we can then move on to resistors. It goes without saying, make sure you place the correct resistor value in the correct location and double check they're correct before soldering them. It'll save you the hassle of desoldering parts. If you're working on a different layout that contains diodes, then that's what you'll want to solder next. But since our pedal we're working on today doesn't have diodes, we'll go to capacitors next. It's best to start with the smallest components first and work your way up to the biggest components last. If we did it the other way around, then it would be hard to get some of the smaller components in the correct place. So for capacitors, you'll normally want to start with ceramic caps first, since they're usually the smallest. Then do film and electrolytic caps next. I decided to use a greeny film cap here instead of a smaller box cap, but either one is fine. As I mentioned in my previous video, the greenies are much less expensive than box caps. However, they're typically larger like this one here. The reason why I chose a greenie is because the circuit is very small, and I know there will be plenty of room in the enclosure, so I can simply bend the cap over to the side like this. If I left the cap standing up straight, then there's a chance that it might be too tall to fit in the enclosure. So for large components like this, make sure you give plenty of legroom to bend them before soldering them on. You don't want these components sitting flush on the board if you plan to bend them to the side. Next, it's time to solder headers for the transistors and sockets for the op amps, if your circuit has them. This circuit only has transistors, so for these you'll want to break off pieces from a header that contain 3 pins to fit the transistors. We're using germanium transistors for this build. Germaniums aren't manufactured anymore as far as I know, so you'll need to buy new old stock germaniums, which can be pretty expensive. But if you shop around on eBay, then you can find them for around $5 each, which isn't too bad. The particular model used for this build is called AC128, but there are several other models that will work too. If you type AC128 on eBay, you'll notice you'll get several different models in the results that are equivalent and should work completely fine. For example, you can find Russian equivalents like I did, which seem to be the best value. Also, while I'm on the topic of transistors, I wanted to clarify something from my previous video where I talked about the various suppliers you can purchase these parts from. When purchasing transistors and ICs, I highly recommend buying these parts from reputable suppliers such as Mouser and DigiKey, since there are a number of fakes on sites like Amazon and eBay. There are a few exceptions, such as germanium transistors, since you can only get new old stock of these. So like I said, eBay would be the best place for these. For other ICs, it really depends. eBay can sometimes have good deals, but like I said, you run the risk of fakes for certain parts, especially JFET transistors and op-amps. So I recommend getting transistors and ICs from Mouser or DigiKey. Keep in mind those sites charge around $8 for shipping, so plan ahead and make a list of everything you might need before ordering. Now this is a good time to talk about HFE values in transistors. The HFE is the gain factor of that particular transistor, and many multimeters will have a mode to measure this. Silicon transistors, such as the 2N3904 that we're using in our build here, will typically have really good tolerances, meaning if you buy a pack, then all their specs will be extremely close, and they will all perform almost exactly the same. However, that's not true with germanium transistors. The tolerances for germaniums are a lot worse, which means that several transistors of the same model might have very different HFE values. That's why when building a pedal with germanium transistors, you'll probably want to measure their HFE to make sure they're a sensible value, or else the pedal might not sound the way it should, or in some cases you might not get output at all. Also, many eBay listings will include the HFE value, so you know before ordering. If you read the comments for this particular circuit, you can find the suggested HFE values for Q2 and Q3, which happen to be different. It's not essential that you follow these ranges, but again, if your transistors have HFE values that are way out of this range, then it's possible your pedal might not work correctly. Be sure to Google the model of your germanium transistors to find the pinout for them, as it's important to orientate them correctly. The collector, base, and emitter pins need to be correct. Also, germanium transistors are much bigger than silicon ones, so it's probably necessary to bend the legs like this so that they aren't too tall to fit in the enclosure. I decided to also bend over the silicon transistor too, although it's usually not necessary. Now let's talk about soldering the wires and pots, which is the last thing we need to do before we can test the circuit and jam with it. As far as colors go, you don't really need to follow the layout, just choose whichever colors make sense to you. But it's usually a good idea to make sure the power and ground wires are red and black respectively. It's best to use stranded wire instead of solid core because stranded wire will hold a lot better in situations like this, where the wires will move a lot when we're installing it in the enclosure. Make sure each wire is long enough to get where it needs to go. It's better to make a wire too long than later find out that it's too short, but generally making each wire between 4 and 6 inches should be plenty. To play it safe, you might want to grab the enclosure you plan to use and visualize how you're going to lay everything out in the final build. After cutting the wire and stripping about 1/4 inch off each tip, make sure you twist the strands a bit to make it easier to insert it into the appropriate hole on the strip board. Make sure there's no loose strand sticking out or it might cause a short with a nearby component or wire. Next, you'll need to solder the wires to the pots. You'll see at the bottom of the diagram the required pots you'll need and what each one does. For example, the volume is a 5K linear pot. The wires coming out of the layout indicate which pot and lug they need to be connected to. You'll see volume 2 here and volume 3 up here. So solder these to the pot following this pin out here. I recommend wrapping the wire around the lug before soldering it. Also, take note the last line that says volume 1 and gate 1 and 2 to ground. This means the first lug of the volume pot will be connected to ground, along with the first and second lug on the gate pot. So go ahead and solder another ground wire to the board for these connections. Also, notice how some wires are connected to multiple pots and lugs. In cases like this, you can daisy chain a wire from one pot to another. After you finish wiring up all the pots, we're almost ready to test it out. But first you need to decide how you're going to hook everything up. I recommend building a Beavis board like this, so you can easily connect your circuits to your guitar, amplifier, and power supply. You can also buy a pre-made board like this, or this one if you want something more affordable. If you plan to build your own, I'll leave a link in the description that contains good schematics and instructions to do this. To power it, I suggest using an adjustable linear bench power supply like I have here. But of course, you can also power your pedal from a 9-volt battery or a power supply that's specifically designed for guitar pedals. If you decide to use a pedal power supply and rig something up with alligator clips, just remember that they are center negative outputs, which is the opposite of most DC outputs. So be sure to measure the voltage and check the polarity before connecting your circuit to it. I'll go into more detail on this later in the next video when we install the circuit in the enclosure and solder the DC jack. Alright, so I've got everything hooked up now and we're ready to hear how it sounds. So I've actually been playing around with it for a little while already to get the hang of it and to know what each knob does. So I currently have it set for more or less on the same settings of the clip that you heard earlier. Also I'm running the guitar through a Marshall clone that I built and made a video about before, so if you're interested in seeing that, I'll leave a link to that. But anyway, so here's how it sounds without the effect. Alright, so now I'll try to play the same song that you heard earlier. Pretty close, huh? So, there's a few other interesting tones that this pedal could do. And, for example, there's that glitchy sort of 8-bit, synthesizer sound. This would be good for, like, mimicking the old school video game sounds. Here, let me show you. So yeah, some people might call this pedal like one trick pony or several trick pony because there's a handful of distinct sounds that sound really good, but everything in between can be hit or miss. So I'll play around with this pedal more, and in the next video, I'll see what else I can do with it. So anyway, that was just a quick demo for today. So what do you guys think of the build? Let me know in the comment section. Now if yours isn't working, there could be a number of reasons why. If everything looks correct, then one of the more common issues are unintentional bridges between the traces. Sometimes they can be so small that you can't see it, in which case you'll want to reflow all the solder joints. In my next video, I'll be showing how I create the graphics and paint the enclosure before finally boxing it all up. So if you've been following along but haven't subscribed yet, then consider doing so you can get notified when the next video comes out. As always, thanks for watching, and I'll see you in the next one.